So students, starting again the alcohols, phenols and ether, and in this chapter we are going to study the next topic, that is the method of preparation method of preparation for phenols. In the last classes we have studied about the preparation of alcohols, okay, means aliphatic alcohols we have studied. Now we are going to see the preparation for the aromatic alcohols, that is called as phenols. So in this particular topic we are going to see different preparation methods for the preparation of phenols. So in this, the first topic which we are going to see is preparation of phenol from benzene sulfonic acid. Okay, so benzene is sulfonated by using oleum. Benzene is sulfonated to benzene sulfonic acid with oleum, which is a mixture of H2SO4 and SO3. Okay, it is a mixture of H2SO4 and SO3, and in laboratory this method is used. So here the the acidification, okay, the acidification of the benzene is carried out first. So here first we are going to convert the benzene into sulfonic acid, okay, benzene sulfonic acid, and for this we would be acidifying the benzene group. H2SO4 plus SO3 gives, this is the sulfonation, okay. So here we will get HSO3, okay, that is benzene sulfonic acid. Now on reacting benzene sulfonic acid with a base, with an alkali, water will be removed out from here and sodium benzene sulfate will be formed. Sodium benzene sulfate will be formed. Sulfonate, sorry. Sodium benzene sulfonate will be formed out here, and with further reaction of sodium benzene sulfonate with alkali in its fused state at 572 to 73 to 623 Kelvin temperature, Na2SO3, that is sodium sulfonate will be removed out and water will be removed out from here, leaving sodium phenoxide, okay, sodium phenoxide. So after formation of sodium phenoxide, the next step will be here to acidify the sodium phenoxide. So on acidification, NaCl will be removed out here and we will get phenol. Okay, we will get phenol. So this is the process of preparing the phenol from benzene sulfonic acid. Okay. Next, the next method is to prepare phenol from diazonium salts. Okay, to prepare phenol from diazonium salt. So here benzene diazonium salt, a solution of benzene diazonium salt on warming will give phenol. Okay, the solution of benzene diazonium salt on warming will give, it will produce the phenols. So benzene diazonium salt means 2 plus Cl minus, it is benzene diazonium chloride. Okay, benzene diazonium chloride, when it is heated with water, or it is first converted to solution, then that water is being heated till a very low temperature, the warming of this particular solution will be done. So we will obtain here phenol, nitrogen gas and hydrochloric acid. Okay, this will be obtained out. Similarly, benzene diazonium chloride can be reacted, okay, can be reacted with aniline with nitrous acid. Okay, it can be reacted with it can be also formed we have to form this benzene diazonium salt. So for that we can use the aniline which is treated with nitrous acid and HCl, and it is been kept at a low temperature of 0 to 5 degrees Celsius. Then the production of N plus NCl minus, that is N plus NCl minus, that is benzene diazonium chloride will be done here. Okay, it will be prepared out here, which is written as N2 plus Cl minus. This is benzene diazonium salt. Now this benzene diazonium salt, on making a solution with water and then warming that solution, it will give phenol. Okay, so this is the process for preparing phenol from benzene diazonium salt. Next is the by decarboxylation of decarboxylation of sodium salt of sodium salt of salicylic acid. Decarboxylation of sodium salt of salicylic acid. Okay, so phenol can be prepared by fusing. Okay, phenol can be prepared by fusing sodium salicylate. Okay, sodium salicylate with soda lime, that is NaOH and CaO's mixture. NaOH and CaO's mixture, followed by acidification. Okay, then after this particular reaction, it will be acidified. Okay, acidification will be carried out here with dilute sulfuric acid, dilute hydrochloric acid. So the reaction here, it will be chemical reaction here, it will be salicylic acid. So the sodium salicylic acid is sodium salicylate. Okay, this is sodium salicylate. It is been reacted with soda lime. So soda lime is nothing other than a mixture of calcium oxide with alkali, that is sodium hydroxide. So here removal of sodium carbonate will take place and sodium phenoxide will be formed out. Sodium phenoxide will be formed out. And sodium phenoxide by acidification can be easily converted to, okay, it can be easily converted to phenols, and NaCl will be removed out, and we will obtain phenol. So first sodium salicylate is converted to phenoxide, sodium phenoxide, by using soda lime and heating it to remove sodium carbonate. Then acidification of sodium phenoxide is taken place, where NaCl will be removed out and phenol will be produced. Next is from the Grignard reagent, from Grignard's reagent. So when oxygen gas is bubbled, when oxygen gas is bubbled, so here when oxygen gas is bubbled, okay, the process is that when oxygen gas is bubbled through an ethereal solution of phenyl magnesium bromide, phenyl magnesium bromide, that is Grignard reagent, then it will form an oxy compound, which upon hydrolysis will produce, which upon hydrolysis with dilute mineral acids, gives phenol. So the general process here it will be, we will be using a Grignard reagent which is formed by a aromatic compound. Here R will be the aromatic compound. We know that the Grignard reagent's formula is RMgX. So here the R will be a we will use a aromatic compound here in the place of any aliphatic compound, okay, in order to produce the phenols. So in this, the Grignard reagent is phenyl magnesium bromide, which is reacted with oxygen in the dry in the dry ether, that is it is a solution which is made in ether. So here uh, compound oxy magnesium bromide, phenyl oxy magnesium bromide will be formed out, okay, phenyl oxy magnesium bromide will be found out. Then after that, on hydrolysis with any mineral acid, we will obtain phenol and magnesium hydroxy bromide. Okay, magnesium hydroxy bromide will be found out. So these were the laboratory methods for preparation of phenols. Now let's see the industrial methods or the commercial methods for the preparation of phenols. Industrial methods for the preparation of phenols. So in this, the first method is from chlorobenzene. Okay, from chlorobenzene, how we can prepare the phenol. This process is known as Dawes process. Okay, Dawes process. So here, phenol is manufactured by heating chlorobenzene with 10% aqueous solution of sodium hydroxide at about 623 Kelvin under 300 atmospheric pressure atmospheric pressure, and in the presence of copper salt acting as catalyst to form sodium phenoxide. Then the sodium phenoxide or the sodium salt, when treated with HCl, gives phenol. Okay, it produces phenol. And this is the dose process, DOWS, dose process. So here we are preparing the phenol from haloalkane. Okay, so haloalkane is chlorobenzene here. Chlorobenzene is reacted with sodium hydroxide, which is formed in a solution of 10% solution with water, and a temperature of 623 Kelvin, 300 atmospheric pressure, and copper salt is taken as catalyst here. So here NaCl and H2O will be removed out. So on removal of NaCl and H2O here, we will produce sodium phenoxide. Sodium phenoxide will be produced. And on treating sodium phenoxide with hydrochloric acid, NaCl will be removed out here and we will obtain alcohol. Okay, sorry, that is phenol. The alcohol which is obtained here, it is phenol. Next is the preparation of phenol from cumene. So phenol is prepared from cumene, and cumene is nothing other than, cumene means isopropyl benzene. Isopropyl benzene. Okay, so for preparation of cumene, Friedel-Crafts alkylation of benzene will be done. Okay, cumene is prepared. Okay, cumene is prepared by Friedel-Crafts alkylation of benzene with propene in the presence of phosphoric acid at 523 kelvins. So here we will convert benzene to cumene by reacting it with propene at 523 Kelvin and in the presence of phosphoric acid. The Friedel-Crafts alkylation will take place and CH3, CH, CH3 will be formed out. Next, this cumene is oxidized. This cumene is further oxidized in the presence of air to cumene hyperoxide, which on hydrolysis with dilute sulfuric acid will give phenol and acetone will give phenol and acetone. So the reaction here it will be cumene isopropyl phenyl, okay, isopropyl benzene. It is been reacted with, sorry, it is been oxidized. In the presence of air, it is been oxidized. Then it is producing, on oxidation of cumene, we will produce cumene hyperoxide. Cumene hyperoxide. This cumene hyperoxide is then further hydrolyzed in the presence of dilute H2SO4 to produce phenol and acetone. Okay, phenol and acetone will be formed out. Next method is from benzene only. Preparation of phenol from benzene, and this process is called as Raschig method. Raschig method. So here vapors of HCl acid are passed over benzene at a temperature of 500 Kelvin in the presence of copper chloride catalyst and ferric chloride catalyst. With excess of air to form chlorobenzene. First we are preparing here chlorobenzene. Then steam is then passed through, okay. Then we will pass steam through chlorobenzene. Steam is passed through then chlorobenzene at a high temperature of 800 degree Kelvin in the presence of silica, in the presence of silica as catalyst, as catalyst to give phenol. This process is known as Rastrich's process or Rastrich's method. So here the chemical reaction is first to prepare chlorobenzene. So benzene is reacted with hydrochloric acid in the presence of excess of oxygen from the air, in the presence of copper chloride and ferric chloride as catalyst at 500 Kelvin temperature to produce chlorobenzene with water. Now this chlorobenzene is reacted with steam, or steam is passed over this chlorobenzene to give SiO2 at 800 Kelvin temperature. Here phenol will be formed out with hydrochloric acid. Okay, with hydrochloric acid we will form phenol. So this was the preparation methods for phenols. Let's discuss about the physical properties of alcohols. So the first, physical state. At ordinary temperature the lower members are colorless liquids. Okay, they are colorless liquids having a characteristic smell. Having a characteristics smell and burning taste will be there. And burning taste. The higher members, that is more than 12 carbon, more than 12 carbon, are colorless, odorless, wax-like solid. Okay, they will be colorless, odorless, wax-like solids. They form hydrogen bond, intra-hydrogen bond. Okay, sorry, inter-hydrogen bonds. And due to this fact, there will be large difference in the electronegativity of the due to the large difference in the electronegativity of the oxygen and hydrogen. Here the hydrogen bonds will be founded, and that hydrogen bond will be also very strong. Okay, let's say this is an example for showing the hydrogen bonding for the alcohol, any alcohol here. So here, due to presence of large electronegativity difference between alcohols, oxygen and hydrogen, we will see that they are forming hydrogen bonds. Okay, and due to this reason, the lower molecules of the lower members of the alcohols are liquid in liquid state. Next, boiling point. So the lower members have no boiling point, but with increase in molecular mass, but with increase in molecular mass, boiling point keeps on increasing gradually. This is due to increase in van der Waals force. Okay. So here we can take example that the primary alcohols are having higher boiling point as comparison to that of the secondary alcohols, as comparison to that of the tertiary alcohol. So here we can see for primary alcohols such as butane 1 oil. Okay, normal butane, the boiling point temperature is 391 Kelvin. For secondary alcohols such as OHCS3, that is butane 2-ol, it is 373 Kelvin. And for tertiary alcohol, it is 356 Kelvin. So the boiling point is decreasing with the change in the types of alcohol, that is primary, secondary, and tertiary. Here, on increasing the molecular mass also, we will see that there is decrease. Okay, if we are comparing the temperature, okay, boiling point temperature with the other compounds, with the other hydrocarbons, then we will see that alcohols are having more boiling point as comparison to that of the dimethyl ether or propane, that is alkanes. So the reason here is that due to presence of the hydrogen bond, okay, due to presence of the hydrogen bond, they are possessing higher boiling point temperature as comparison to that of the other hydrocarbon compounds. After this, let's talk about the solubility. Solubility. So the lower members of alcohols are highly soluble in water, but the solubility decreases with increasing molecular mass of alcohol. Okay, and the reason for the formation of and the solubility of lower molecules of alcohols is more with water due to the formation of hydrogen bond between them. Okay, they can easily form the hydrogen bond with them, and therefore they are having high solubility. Next is the density. Generally alcohols are lighter than water, although the density increases the density increases with increasing mass. Next, let's see the physical properties of the phenol. So for phenol, the physical state, for physical state of phenol, they are colorless crystalline solids or liquids. They have characteristic phenolic odor. Phenolic odor. Phenols are sparingly soluble in water. Due to their non-polar nature, they cannot be soluble in water. Okay, and also phenols are having high boiling point. Okay, phenols are having high boiling point than other haloarenes due to presence of hydrogen bonds. Okay, for taking example of the toluene. Okay, we will see that the temperature for the boiling point of toluene, it is 384 Kelvin, while the phenol, it is having 445 Kelvin temperature. Okay, so here the boiling point is high due to the presence of the hydrogen bond which I am showing here by this particular diagram. So here del negative, del positive, del positive, del negative, del positive. Okay. Due to this behavior, we will see that they are possessing higher boiling point temperature as comparison to the other halo arrays. So for today, I am concluding the class here only. In the next class, I will start the chemical properties or the chemical reactions of the alcohols and phenols. Okay, so today I am closing the class here only. We will meet in the next class. Thank you.